Okay, here's another first order reaction example. At room temperature, hydrogen peroxide has a half-life of 20 days. So here's the decomposition reaction. Hydrogen peroxide decomposes to form water and oxygen gas. This isn't terribly dangerous. You can actually see this on a wound, hydrogen peroxide giving off bubbles. That's oxygen. This naturally occurs at room temperature. The half-life is 20 days, and after a while on the shelf it goes bad. So this is what we term the shelf life of something. When the solution has decomposed and 80% of the substance has decomposed, that means 20% remains, or 20% is good still, then the substance is considered expired and the store needs to throw it away. So we want to calculate how much time does that take. Okay? At what time will the solution decompose? First thing you want to do is use the half-life equation for a first order reaction. Okay, we are given information about the half-life in days. We need to solve for K. Go ahead and plug in the half-life, which is 20 days. D here stands for days. Log of 2 is 0.693. Make sure you're using the LN button on your calculator. So 0.693 divided by 20 is 0.03465. Per day, or inverse day, or reciprocal days, D minus 1, those are all the same thing. Okay? Now that we know the rate constant, we can turn our attention to the integrated rate equation for first order reactions. Natural log of A naught, the initial amount, minus natural log of AT, the amount at time t, is equal to K times T. Okay, we're trying to find out the time here. We know the rate constant from the first part of the problem that we just calculated. And what do we do here for A naught and AT? Well, we have this information here, 80% decomposed. 80% decomposed means 20% good. But first, let's solve for time by dividing both sides of this equation by K. And now we want to recognize that this 80% means 80 over 100, or 20% good, 20 over 100. Okay, so 20% undecomposed, or 20% good reagent, or 20% hydrogen peroxide remaining, okay, is what we're going to use. 20% means nothing more than 20 divided by 100. So don't give up when you see this type of problem. Just think carefully about it. 80% decomposed means 20% remaining, or good. A percent just means divided by 100, so 20 over 100. The initial amount we can just arbitrarily set to 100, and the amount at time t we can just say is 20. Okay? And this ratio, 20 over 100, is 20%. That's all it means. So pay attention to the words in the word problem. If it says 80% decomposed, that means 20% remains. Okay? And I've just chosen to calculate this problem in terms of setting 100 to A naught. Okay? So we want to go ahead and plug 20 in place of AT in this equation, and 100 in A naught. Okay? So initially we had 100%. And after a long time we have 20%. So that means 80% has decomposed. Does that make sense? Next, it just becomes a calculator activity. So we want to take the natural log of 100. Be certain to use the LN button on your calculator. We want to subtract the LN of 20. Okay, so that's 4.61 minus 3. You'll notice that when we do this, we have a positive number, okay, in the numerator. Divide by 0.03465 per day, and we get 46 days. So that means at room temperature, the bottle of hydrogen peroxide you buy from the store is going to last a little less than 2 months, about 46 days. If you want this substance to last longer, put it in a refrigerator. Okay?